as you have probably noticed by the title of this video, we will be talking about telescopes. And I'm going to start by busting a myth, and that is that telescopes just zoom into objects like you would just use a magnifying glass or you zoom into a photo on your phone. So, if they don't simply zoom in, how do they actually create an image of something so far away? That's the question we'll dive into, along with many others. But to get there, first I'm going to introduce you to some of the main parts of the telescope. There are actually three types of telescopes: refractors, reflectors, and catadioptric telescopes. So, let's begin with the type of telescope that Galileo Galilei first invented, and that is a refractor. Now that we magically have this photo of a telescope, let's begin. So, refractive telescopes, just like any other type of telescopes, uses a tripod, and that's the tripod right here. It uses the tripod to be able to stay up. Sometimes the tripod can be a bit complex, but in most telescopes for beginners it is pretty simple. Now we have the mount. It allows the telescope to be stable and move around. Most telescope mounts have locking knobs. By loosening these knobs, you can freely adjust the telescope's position in any direction or angle. Once you find your target, you can tighten these knobs to hold the telescope in place. Some types of mounts, especially equatorial mounts, also have counterweights. These weights help balance the telescope, making it more stable and easier to track objects in the sky. So now let's look at the telescope itself. Its main part is the optical tube. Since it holds all the parts of the telescope, I called it the most important one. The material that it's made from has to be lightweight and durable. That is why optical tubes are mainly steel, aluminium, or carbon fiber. At the end of the optical tube, you can find the eyepiece right here. The eyepiece, often referred to as an ocular lens, is a part of a telescope that observers look through to view celestial objects. Different eyepieces provide different levels of magnification, making it easier to look closer at the specific sections of the night sky. And here are a few of my dad's eyepieces that I borrowed. Oops. Each is labeled with its focal length right here, which affects the magnification. They vary in size, as you can see, and power, and are usually easy to swap on a telescope. To change an eyepiece, you simply loosen up the locking screw, which goes right here, slide the eyepiece in or out, and then tighten it again. Under or around the eyepiece, there's a focuser mechanism that includes locking knobs used to adjust the focus of the image. This adjustment is important because different people may perceive images differently. For example, my sister, who wears glasses, might see a blurry image through the telescope if the focus isn't set correctly, while I might see it clearly. That is why she will need to adjust the focuser to the image sharp and clear for her eyes. On top of the optical tube, there is a finder scope. It's attached to make finding objects easier and more precise. Most finder scopes have low magnification and wider field of view compared to the main telescope, allowing you to quickly find objects in the sky. They typically feature a crosshair, which should look like something like that, or a reticle, which if you look through it will look something like that. This helps you to aim accurately. Using a finder scope is very important because finding objects without it can be quite challenging, and for me it can feel almost impossible. Now let's look inside and see what makes refractors different from the other types of telescopes. Refractors use lenses to bend or refract light, which is reflected in their name. At the front of the optical tube there is a large objective lens right here that gathers and focuses light. At the eyepiece there is a smaller lens that magnifies the image produced by the objective lens. This combination of lenses allows refractors to create clearer images of celestial objects. Now, we finally reached the part you have been waiting for, and that is, how do they actually work? First, I'll have to remind you some of the main properties of light. And that it is featured to move with different speed through different mediums. Light travels the fastest through vacuum, like in space. Slower through air, and even slower through plastic, glass, and water. Because of that, when light travels from one medium to another, it refracts. Now let's get deeper into how this works. Now imagine light traveling from air to water at approximately 299 million meters per second in air at a certain angle. When the light reaches the surface of the water, we can visualize it as a straight line hitting the surface at an angle. So it will look like something like that. The part of the light wave that enters the water first will slow down, while the part that is still in the air continues at its fast speed. This creates a situation where one side of the light wave is moving slower than the other side. So when this light ray hits the water, this part hits the water first, it slows its movement, while this part of the ray, which still hasn't touched the water surface, it keeps its fastest speed. So this way, when one part is slow and one part is faster than the other, the ray will turn and bend to the side that is moving slower. So this means that when the light reaches water surface, it will bend like that. And that is called refraction. Of course, there is some light that is still reflected off of the water surface, but it is not much. A fun fact is that if you put a straw into a cup with water or some liquid, if you put a straw in there, it will actually look like the straw is broken or bended at some point. That's because of the refraction. You can try this experiment at home. Now, let's see how refracted telescopes use this light property to make objects look bigger. So, here we've got our bigger lens of the refractor telescope, which is also called an objective. And here we've got the eyepiece. The eyepiece is usually smaller than the objective and is used like a magnifying glass. And here is our eye. So let's say our telescope is pointed at the moon. The light that comes from the moon will withdraw with two strokes of light, which are going to be two straight lines. So the first one comes, let's say, from here and continues down till it reaches the objective. When it reaches here, the objective, the lens, it bends because it refracts and then continues its way. The second stroke of light will do the same. It comes here, it bends because it refracts, and it continues its way. Now, at some point, these two strokes of light will meet. Where they meet is called a focal point, which we're gonna put like that. And O is for the objective, and F is for the focal point. Now, the distance between the objective and the focal point is called focal length. Now, the focal point is usually where the image is. So, this light that carries the image of the moon refracts right here, and right here at the focal point, it's clear and is closer to the eyepiece, which is what we need, because if we only look it through the eyepiece, it will be blurry since the focal length of the eyepiece is a lot shorter. So it will look a lot blurred, the moon will be blurred. So what we need is the moon to be closer to the eyepiece, right? So that's what the objective does. It moves the image of the moon closer to the eyepiece. So here we've got our moon. And now, let's continue the strokes of light. So they will go right down, and then it will bend right here, and it will refract and come to our eye. The other one will do the same, and there we have it. But now, we haven't mentioned one more thing, because the eyepiece actually has a focal point too. So, right here will not only be the focal point of the objective, but also the focal point of the eyepiece, and E for eyepiece. And again, here we've got the focal length of the eyepiece. Now it's really important the focal point of the two objectives, of the objective and the eyepiece, match, because if they don't match, and let's say the focal point of the objective is right here and the focal point of the eyepiece is right here, the image will be blurry again. So it's really, really important the focal point of the objective matches the focal point of the eyepiece. Next, we've got reflectors. They're usually bigger and wider than refractors, but the main difference in their structure is that their objective is not a lens, but a mirror. This makes them lighter, cheaper, and they produce better images than refractors. Reflectors use another of light's properties, and that is to reflect. So when the light from an object reaches the main mirror, like that, we're gonna draw two strokes of light again. When it reaches the main mirror inside the optical tube, it reflects off of it and reaches the second mirror. This mirror is usually a lot smaller, but when the light reaches the smaller mirror, it reflects again off to the eyepiece. Where here, of course, we have our lens, which makes the image bigger, just like in the refracted telescope. Next, we have catadioptric telescopes. They're a combination of refractors and reflectors, taking the best from each type. They're usually small and light, but the tube is a lot wider. So how they work? Again, a light coming from an object that the telescope is pointed to comes from here through the lens. We're gonna draw two strokes of light again. Through the lens, here it refracts but continues its way down to the first mirror. Here we're gonna do the same, it refracts and then continues its way to the other mirror. Then, off of this mirror, it reflects and reaches the second mirror. It's again a lot smaller. And then off of here, the light again reflects and reaches the eyepiece, which in there we have our lens, which magnifies the object according to the type of the lens. And there we have it. Telescopes, whether refractors, reflectors, or catadioptric, are our gateway to the universe, helping us uncover the beauty of the cosmos. No matter your choice of a telescope, the night sky is full of wonders waiting to be explored. So grab your telescope and start your adventure. And don't forget to like, share, and subscribe for more exciting videos like this. Bye bye.